Welcome to Tech Ranch, a place where we learn and earn technical skills in the most efficient way. Let's make coding fun. Algorithm and implementation. Doubly Linked List Part 2. So today we are going to continue the session from the last session of Doubly Linked List Part 1 and showing you the live demonstration and implementation of operations performed in Doubly Linked List using Java. So before we get into the performance of operations on doubly linked list, let's have a quick review about doubly linked list we have learned in the last session. So we have seen a doubly linked list is a linked data structure that consists of a set of sequentially linked records that called nodes. A node has data and pointers to next node and previous node, just like a regular linked list. The difference in the doubly linked list is we are going to have three parts of a node in doubly linked list. The first node is the previous pointer to null. Last node next also points to null. Iterate over linked list in both direction with these next and previous pointers. It's the best example to understand doubly linked list properties is just a two-way streets where we can go forward and backward parallelly. So you can see here, this is a node which has a blue part is the data and the green part is address. And this address is basically pointing to the previous node for this front address, and for the back address, it is pointing to your next address to the next node. And this is how it is linked. And you can traverse backward and forward both the way. The head pointer is significant of your first node and the last node is equals to null. So now let's take a look at the demonstration for performing operation in doubly linked list. So consider we have a list which is head and tail. Head is your just a regular head address and the tail is equals to the null. And we have some elements and these are the data of a node. And this node has pointer address, previous address and the next address. So in this demonstration, we are going to see the addition of node at front. That's the method we are going to implement is called add first. Adding node at last, iterate forward and iterate backward is basically traversing forward and backward. So in general, if you say we are going to print the list backward and forward. The reason we are showing forward and backward since the doubly linked list can traverse both the way. So it might be one of the requirement you have like going backward and forward in your browser. So these type of features you can implement using doubly linked list. Deletion node front, this is remove first, and deletion node last is your remove last. So these are the method we are going to implement. As you can see the snapshot of this implementation, what we are going to do here, we are going to have a menu and this menu will ask the user to enter the choice and based on the choice we are going to perform these operations. So insertion node at the beginning, insertion node at the last, iterate traverse print forward list, iterate traverse print backward list, deletion at front and deletion at last, and in the end we are going to have the exit. Now let's code on and see how we can implement this. So this will be my Eclipse IDE and I'm going to continue with the same project we had last is doubly linked list demo tr, and in this we have a package. I'm just going to use another class and here we are going to have doubly linked list demo tr. Okay, tr is significance for Tech Ranch. In just and I'm going to have my main method. So if you have remember in the last session we have created the node separate node class, a private class. So similar, this is how we are going to create an object and having a node in your list. So this is how we are going to create, the same way we are going to create it here. The difference here is going to be we are going to have some kind of list significance here. Because this list will have number of nodes which is dynamically created. So what we can do, we can have a list object of a list, and that object of this list is going to create dynamically. That will be more clear when we actually work and show you in the next use of it. So first of all, we need to have the node, and that node has head and tail. So let's have a private node head object, the private node tail. Now it's showing the error what is node. So for that, what we can do, we can just create a private node class. Okay. So this is what we did in the last session. We created a node class, and that node class will have your all kind of definitions. Now it's asking what is E element. The element is basically your list. You're going to have the data, storing the data. Node, next, node, previous. So node, next and previous is basically your address of the next node and your previous node. So this is what we have a node with the definition. Or another part what we missed here, we need to have the some dynamic variable which has mentioned, which is defining your size, so that we can perform the operation and print the list. Now here what we need to do, another thing, to create a node, we need to have the node constructor, and this constructor will have your all parts of a node. You see, next address and a node previous address. So this constructor have the definition of like this: element, and so this operator, I'm going to have another session in the core Java course about this and super soon in detail. So for now, what we can understand is like what is happening. The constructor will point to the current object references. Okay. So we'll show you in the next session in the core Java course. I'm going to have this separate detailed session about this and super keyword. It will be coming soon, so stay tuned for that. And we have our size method, which will basically help you to calculate and keep it handy your size of the list. So we can perform and control the addition and subtraction, and based on that we can easily have the debug your implementation in case if there is any missed pointer we left. So in this way, what we can do, we can make sure that our list is not empty, or is our list is not overfull. So the size, when we traverse it or we try to delete the list, make sure there is an element. If it is not, then it will mention that the list is not does not have any element to display. So you can mention empty, the list is empty. So node, this is temporary node definition. We are going to create, what is happening, we are going to create the first element, the first node. We are creating adding a node in the first position. So for that we need to have the temporary node, which has the definition of your node constructor, and the constructor has your arguments, head, the first position, it will be like this, right? Because the first node in a doubly linked list will have the head and the null, because there is no element. So the last is the first and the last element. So if this condition is true, head is not equals to null, that means the list has some value. So in that case, head previous is equals to temporary. So we will swap the node in that case and assign the value which we wanted to add. So this is how, and in case your tail, that means your last element is equals to null, that means the list is empty. So in that case, temp is equals to tail is equals to temp, and the size will increase, and this is how we can add on our node at the first position. And here we can mention adding is done. and some value whichever we are getting from the user is added successfully. So this is how we can implement the adding first. Now let's do the adding last. For adding the last, this is the same logic and the same implementation is going to happen. The difference, let's take a look. What will be the difference here? Let's give the name first, add last position, right? So last position, and the argument will be element. Node is the same. The difference, since it is at the last position, so your head is equals to null, and the tail will be your some value. Now in case of head, we need to have the tail here. Rest, the everything is going to be same. You see, tail, and instead of previous, it will be next. The rest, tail here, tail, and that wherever you see the tail, change it to head. Now why it is happening? Because the situation is different here. You see, we are adding at the last, so the last situation, last node will have your header equals to null. So head is equals to temp. We need to have the size increment, and your adding element is done. So this will implement your adding last. Now this is our adding last. Now next logic we need to do is iterate forward and iterate backward. So iterate forward is basically printing your traversing your doubly linked list, if you see. So for that, what we can do, public, there is no return type or argument for this type of method definition. It's basically nothing but the displaying the list. So iterating forward, iterating traverse, or printing, whatever you say, forward list. And how we are going to do here, we are going to have the node object, and that has temporary and initialized by head, and printing with the while loop. While loop is easy because we always just check the condition and perform the implementation, do the requirement what we want to do it in the logic. So this will help you to next, yes, and this is all implemented. So you see, this is all we need to do. While loop will check the condition. If temp is not equals to null, then it will print the element and move to the next element. So the address of the next pointer will be assigned to that, and then further it is going to check the condition and keep doing it until the condition is not true, like temp is equals to null, and that means that is the end of the node, the last node of the list. Now we are going to copy in this and paste this, just doing the same way we did it for the backward. What is going to be difference here? If you see, the difference is the condition. What is going to happen here? In case of head, we need to put the tail, and the tail, and the next we need to do the previous. That's it. Because in the backward situation, what we are going to do is we are going to read from the tail, and tail will not have the unnull, right? The temporary node will not have the null when it is initialized to tail. So based on that, we need to make the changes. So this is all about your backward iteration. Now let's do the deletion of the node. So for deletion of the node, first we see the deletion at first. Let's have a definition, method definition. Here we need to have the element as a argument, and remove first. So no argument needed, only the return type. Because what is going to happen here, when we do the, just make sure we have all kind of exception needed so that it will be more efficient coding and easy debugging too. These things can be implemented many ways. Here I'm going to use the element as a return type because we are not going to get any input from the user to remove the node. This is like remove the first. So first we traverse to that location and change the pointer address. Instead of that itself is going to delete it. This is the logic to delete a node in any kind of list or data structure. We just remove the address. So here we are going to remove the address and changing to previous, because here we are going to remove it at the first node. And once this is done, we are going to reduce the size of the list. So automatically your node is deleted from the list. And once this is done, element. So you see, this will print that this particular node, which is located at the first position, is removed, and your return type is going to be the element which we have removed it, which is assigned it in a temporary mode. So now this is what we did it. There is an error of one package, import package. We need to do it. So we can do that. Now just for the first we need to do for the last, and for the last all we need to change the conditions. Now here we did it with the head, and since we are going to do it at the last, so what we need to make the change? Tail. All we need to make the change for tail. Now since it is tail, so we cannot go the next because there is no next in the tail. So what we need to do? Previous. We need to traverse back. So tail, and here we need to assign it for the next is equals to null, so that this will be end of the list. So that's it. All we need to do is next is implementing in the, so in the main method what we need to do is doubly linked list demo, creating the class and creating the object of the class. So instead of E, we are going to have the list of integer type. So we are going to use a primitive type of class, and creating an object, new doubly linked list tr constructor, the termination scanner, so that we can get the value from the user, and we can include the scanner util package dot in, and from right click we can just simply import the scanner package. So this is termination. Now what next is we need to do is we are going to create a menu, like a main menu. So for that we need to have the switch cases, and that switch cases has to be repeated until the user said I'm done with my operation, I wanted to exit from the application. So there we can have the do while loop. So simple, we're going to have the print ln, and just having a formal presentation, that doubly linked list operation demo / n for the new line and the termination. So here we are just going to show some, list down some operation what we are going to perform here, like insertion node at first, front or first location, and just like that termination, and here second option, insertion at last, and we don't have to have the /n because we are using println. That itself will give you your iteration new line, iteration forward, and for dot iteration or printing or whatever you can, traversing, whatever you can mention it here. Having more better presentation, easy to understand anyone. Deletion or removing at front or first. So just a formal presentation to make it more efficient programming and give a choices to the user when they use this. So basically doubly linked list is one of the feature what we used in our regular routine in like backward or forward in the browser, or sometimes run, redo or undo your operations what we did. So system can implement it accordingly. Enter your choice. Now once this is done, next step we need to ask user to enter their choice, and once they did, next step we need to get the value. So I'm going to have it in a integer type. So let's give the integer choice and get the value from the user in the next int method from the scanner object. Now next, let's have the switch implementation where we are going to have the choice as an argument, which basically user is going to enter, and based on that we are going to set the cases. Now in cases we can mention adding at front, right? Adding node at front and calling the method. Your method is basically dll dot add first. Integer is your, instead of having any specific variable, you can directly get it and store it and get it from the like this. Simple and efficient. And break. This will automatically add it in your list, element list, and printing and save it. Case, or now instead of having another separate presentation, you just can copy and make changes accordingly. You don't have to get little stressful if there are any errors. All it happens, we can learn from it. I'm just making it easy. Next our option is iteration, right? So let's have the iteration forward, and for that all you need to have the method iteration forward. See, just quick and iteration backward, iteration backward. And option 5 is your remove from the front node, removing the first node, right? So termination, of course. Your case 6 will be your removing from the last. Deletion node from at last or at the back, whatever you can mention it. So the difference here, we don't have any argument, since it will just traverse it and delete it from the node list at that position. And another point is 7 is for the exiting. So just mention goodbye. And no method implementation needed, just for the presentation and formal better coding. Now once this is done, we need to make sure the user will not give any other unknown case choice. So what we can do is just having an invalid choice case is called default. We have to break, of course. Once the break is done, your switch is done. Next we need to ask user if user wanted to continue. So for that, do you want to continue? Yes or no. Give some signs to enter the value from the user, and that can be used for as a character and get the value. Next dot char at index will be your 0, since it is only the first character. So this is like character array where the location 0. So whatever the user entered here will be considered as the character variable. And is that duplicate variable? Okay, we have already made the variable. We don't have to declare it again. Now once this is done, we need to close the do while loop, and for the do while loop closing, we need to give the condition of the while loop. If user entered y character, that means he wanted to continue. So that's the only thing we need to make, and make sure that it is not case sensitive. So for that, we just have the condition like simple condition like this. And I guess this is all implementation of needed. I think we missed termination of do while loop here. This is what we needed for termination of do while loop. Let's take a look at the execution. Since it's a Java application, so all we need to have the Java application. I might need to open the console window. This is the console window. If you see, it's showing the menu to me. So this is the execution of doubly linked list operation demo. You can see the menu here. First thing, I need to start from the adding a node at the front. So I give the number 1 and I enter the list node. I wanted to continue. I'll give another choice, and that is 1, and I'm adding 45. Now I wanted to continue again, and I wanted to see the list. So I wanted to have the iteration forward, and this is my list 45 and 23. I wanted to continue again. Now this time I wanted to add at the last. So I'm going to give the choice 2, and having a 67 node adding at the back. So we have 45, 23, and now 67. So technically, if you see this time, if I'll see the iteration forward, what should be the output? It will be 45, 23, and 67. Let's see. So here, the 67 is added at the last. Now, in case if I wanted to delete now, let's take a look at the deletion. Do you want to continue? Yes, I wanted to delete at the front. So my front node, which is 45, is deleted. Do you want to continue? Yes. Do you want to see the iteration on the traversing and the printing the list backward? So that is 4, and the 4 backward where 45 is deleted. Now this will print as a 67 and 23. So you see, I wanted to continue and deletion at the back. So for that, I'm going to enter the choice 6, and 67 is deleted. This is a backward printing. So basically the list is 23 and 67, and now it is deleted. The 67 is deleted. So if you see, now I wanted to add at the back. So I can give the choice 22 and add it 89. Do you want to continue? And again, I added 56. Do you want to continue? Yes. Now let me print it this list forward. So 56, 23, 89. So this is the live implementation and demonstration of doubly linked list, performing some insertion, deletion, and traversing and printing backward and forward. So we have seen the complete implementation of doubly linked list in detail. In the last session, we have seen the differences between the single linked list and the doubly linked list. The single linked list occupies less memory as it has only 2 fields, less efficient access to elements, node with only a data field and next link field, whereas in doubly linked list, DLL occupies more memory as it has 3 fields, more efficient access to element because of it is two-way feature. nodes with a data field, a previous linked field, and a next linked field. This type of data structure is being used when we need to traverse or browser the previous and backward and forward, or sometimes we are adding anything and we need to redo or undo the things what we did, typing in the some kind of software application. So those places we can use this kind of feature and logic, and it's pretty important feature of data structure. Thank you so much for watching this video. For any kind of assistance and source code needed, please contact techcrunch2019@gmail.com, and stay tuned for more upcoming interesting and informative sessions. Let's make coding fun. Thank you.